Okay, welcome back. Question number 16, our emergency revision for the calculator paper. Okay, question 16 is to do with Pythagoras theorem. ABC is a right angle triangle. Soon the mention with right angle triangle, and you got to work out a length. Okay, you have two lengths you already know. You should be straight away thinking about Pythagoras. Now, what is Pythagoras theorem? Pythagoras theorem states that the hypotenuse, sorry about that, bit of a funky Y. Hypotenuse squared is equal to the sum of the other two sides squared. So side 1 squared plus side 2 squared. Okay, that's going to be side 1, okay, and that's side 2, and that's squared. Now, let's label up our diagram. This here is our hypotenuse, 9. So we say 9 squared is equal to side 1, and we'll count it as 6. 6 squared. Folks, don't get confused with the little 1 over here. That's just annotation for meaning side 1, side 2. The powers are actually at the top. Please don't get confused. Okay, so we have side 2. Side 2 will have to be this one here. This is side 2, which is what we want to work out. AB is equal to side 2. So that will be AB squared. Now, what we want to do in this question number 16 is worth 3 marks. Okay, so we start off with our basic formula. There's lots of variations of how you might have learned this formula. So it's just the way I teach it. Okay, so there's variation where, for example, we have A squared is equal to B squared plus C squared. There's even variation with A squared plus B squared equals C squared. It doesn't matter. The rule is hypotenuse squared is equal to the sum of the other two sides squared. That is the asal, or the origin of the question. Now, we've got to work at AB. AB is being squared. That's the first action. It's being added by 6 squared. Second action. So now when you solve it, move the last action first. Opposite of add 6 squared is minus 6 squared. So I was going to rewrite it down here to make it a bit more neater, a bit more clearer. 9 squared minus 6 squared is equal to our A, B, the side, but is equal to that is squared. Now, if you see what we're looking for, we are not looking for the squared. We got to get rid of the squared. So what do? We need to grab the squared. That's the last action. That's the last thing for us to move now. Opposite squaring something is, squaring on one side is to square with the other side. So we just rewrite it again for niceness and tidiness. So 9 squared minus 6 squared, all of it square rooted, is equal to what we're actually looking for, which is AB. Now, you can even put 2 down here if you want. That makes you happy. That means time to get square root. 3 would be cube root. So here's our AB. Now we need to grab our calculator. Okay, right. We need to type all of this into the calculator. So we start off with the square root sign, which in this particular calculator I have to press shift and square root. Okay, oh no, is it there? No, sorry, we didn't need to do that. Let's just delete that. We can just press shift square root. Okay, here we go. So 9 squared minus 6 squared. So 9 squared minus 6 squared. 6 squared. So this here looks like this. Press equal. And that gives us 6.7. Let's write those numbers down. So we have now 6.708 blah 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 blah. Okay, now we're looking for 3 significant figures, folks. That's the key thing in the question. If you don't give the answer to 3 significant figures, you will definitely lose marks for not following the examiner's instructions. So here's our first significant figure, here's our second significant figure, and here's our third significant figure. Remember, significant figures are to do with your first non-zero digit, which is the 6. Second non-zero digit, and even though we got zeros later on, it doesn't matter. So first significant figure, once it's not a 0, it starts first, second, third, regardless of whether it's 0 here or not. So let's have a look what we do next here. Okay, so 1, 2, 3 significant figures, put line down here. I'll call this my last digit. I'll call this one here my decider, the important one, the decider. And so we say, if the decider, if this decider here is 5 or more, we add 1. Because it is 5 or more, we need to add 1 to the last digit. So we add 1. Okay, so now we have 0 add 1 is 1 and not 6. Okay, that's a joke I think really one of my students, one of my YouTube students, Zongui, will understand. Okay, hopefully we have a little bit of laugh like that. Okay, then copy with 7, add the nothing here will give you 7. Copy down the point, and this is, I hope all of this has come onto the video and we haven't lost anything. So the answer should be 6.7123 significant figures. I'll write over here for more clarity. 6.71 is the length in centimeters to 3 significant figures. Okay, folks, that's how we do question number 16, a Pythagoras theorem question. It is worth 3 nice marks. Okay, this question is the one we have to rearrange it. Start with this formula, put your values in, rearrange it, put in a calculator, do it. This is nice, 3 marks in the bag. We'll see you in the next question, inshallah. Okay.